Hello. In this lecture, we will see how Phase 1 aggressive mode works. So Phase 1 aggressive mode cuts down the messages from 6 to 3. In the first message, the initiator would send the ISA-CAMP SA. This specifies what transforms the client would like to use. It generates a Diffie-Hellman private and public key. It sends the Diffie-Hellman public key along with the message. So the transforms has the list of encryption, hashing algorithms and Diffie-Hellman key groups that it would like to use. It's going to select its preferred algorithms, generate its Diffie-Hellman private key and public key. It will then send the header with the security association, its public key and the nonce for initiator as well as its ID. The ID portion is typically a group ID as the IP address of the initiator is not known ahead of time. This will be sent to the firewall or gateway, which is the responder in this case. If the responder accepts the proposal, then it's going to generate the Diffie-Hellman private and public key. It will then calculate the authentication digest, which basically validates the authentication of the client that initiated the connection. It is going to send the response with the digest. And digest basically, it's a hash function to validate the authentication. And then it's going to send it to the initiator. The initiator would send an authentication proof, which basically is the group ID or key used in a hash function that validates the initiator to the responder. Aggressive mode doesn't require the firewall to know the IP addresses of the connecting clients in advance. That's the whole premise behind the aggressive mode. But the implementation of aggressive mode typically uses a group ID or group name to look up the pre-shared key. And that's what typically you would see in the implementation. Let's see this in slow motion. The first message has the header with the SPI initiator set. SPI responder is not set, the same like the main mode. That's because it doesn't know the responder index yet. The security association. What proposals it's proposing. The Diffie-Hellman public key based on its preferred proposal. And the nonce that's used in the functions to generate keys, like we saw in the main mode. The ID of the initiator, which is typically a group because the IP address of the initiator is not known ahead of time. So in that case, it's going to send the group instead of an IP address. Once the responder gets the message, it will pick the Diffie-Hellman group, the same like what was used in the initiator message. It's gonna select the encryption and hashing algorithms. Then it is going to calculate the shared secret key based on its own Diffie-Hellman public key that it generated. It generated the public key, and it hasn't sent it yet, but it generated it. And it's going to basically calculate the shared secret key based on that. And it's going to come up with a nonce, a number used once for the responder. Based on the group information, the responder would look up the pre-shared key and calculate the seed key. Same like the main mode. It is going to calculate the phase 2 key, the authentication key and encryption key. It is going to calculate the hash for the responder. And the hash for responder, basically, we take the seed key, the Diffie-Hellman public key for the initiator that was received from the initiator, the Diffie-Hellman public key that it will send back to the initiator. This is the Diffie-Hellman key responder. It is going to send the cookie for the responder, the one that it's going to send in the new message. It's going to use the cookie for the initiator, the one that was received from the first message. It's going to take the security association payload, and the ID of the responder, which has its own IP address, typically, and then it's going to send that message out. This message would have the accepted proposal, its own Diffie-Hellman public key and number used once and the ID of the gateway. And the hash of the responder. So the ID of the responder, that's going to get used in by the initiator to calculate the hash for the side. We are going to see this in a minute. So, now that the initiator has the Diffie-Hellman public key of the responder, it can calculate the Diffie-Hellman shared secret key. And based on that, it's going to calculate the key seed and the SKIDD for phase 2. It will calculate the authentication key and encryption key. And then it's going to run the same hash that was used by the responder to validate that the hash from the responder was correct. It's going to calculate its own hash. And in that case, it uses the same function. It transposes the public key for the responder first, instead of the public key for the initiator, then cookie initiator, cookie responder. The security association, and the ID of the initiator, which is the ID, in this case this is the group name that was used. And then it's going to send out the message with the header that has the information about the connection and the hash of the initiator. It's going to encrypt that message with SKIDE. And then it's going to send it on to the other side. The other side will decrypt the message with the SKIDA that was pre-calculated after receiving the first message. And then it's going to validate the hash, and then both sides authenticated each other. So if you look here, this is the authentication. The last message is the authentication proof where the initiator is proving its own identity to the responder. The pre-shared key is used, and here it's looked up based on the name of the group that was sent by the initiator. So if we look at a packet capture, here are the 3 messages. First message has the security parameter index initialized for the initiator side, not for the responder. The security association, which has all the transforms, the proposals that it's recommending. Here, there's multiple proposal proposed. You have proposal 1, proposal 2, 3 and 4. This is called the SAI. This is the message that's going to get used to calculate the hash R and hash I. Both hash R and hash I uses this message. And the first one you see here, it's sending the key. This is the Diffie-Hellman public key of the initiator. It's sending the nonce, which is the number used once generated to be used in the calculation of the key seed. And it's going to send out the message. The second message has both SPIs, as both SPIs are initialized. And the accepted proposal is sent. And this is the proposal that was accepted by the firewall. It sends the key, the Diffie-Hellman public key of the responder, the number used once that's going to get used in calculating the seed key. And it is going to send it off. The last message is encrypted. Let's look at the second message. If we look at the second message, we should see the hash. Let's take a look here. We see the nonce and the identification. Next payload is hash. This is the hash of the responder. This is the hash that was calculated. It is calculated by a function that uses the Diffie-Hellman public key initiator, responder, cookie initiator, security association, and the ID of the responder. The last message is encrypted. We see here encrypted data. And basically what's inside the encrypted data is the hash I. Hash I is the hash of the initiator encrypted with the key with SKIDE, and then, the responder would decrypt it and identify. It will run the hash I calculation to figure out if it was correct. Then both sides authenticated each other. The next step is to authenticate the user, which is done using XAuth. We will discuss XAuth in a future lecture. See you in the next lecture.